The next topic is the standard normal distribution. Now, the standard normal distribution is a special case of the normal distribution where the mean is equal to 0 and the standard deviation is equal to 1. So if you look at the graph, you can see that the mean is 0 and the standard deviation is 1. We are also looking at z-scores, and these are associated with the standard normal distribution. And it describes how many standard deviations a data item in a normal distribution lies above or below the mean. It can be used to compare two sets of data. And for z-scores, the mean is equal to 0. So if you look at the graph for the standard normal distribution, we have a z-score of 0 at the mean. We have a z-score of 1 when it's one standard deviation to the right of the mean. And we have a z-score of -1 when it's one standard deviation to the left of the mean. So these are z-scores. And we have a formula for calculating z-scores, and that is the data item minus the mean divided by the standard deviation. And using symbols, that's x minus mu over lowercase sigma. A set of data items is normally distributed with a mean of 60 and a standard deviation of 8. Convert each data item to a z-score. So we want to use our formula. 76 minus 60 over 8 is equal to 2. So this means that a score of 76 is 2 standard deviations above the mean. So a 76 is very good. 40 minus 60 over 8 is equal to negative 2.5. So this means that a score of 40 is 2.5 standard deviations below the mean, or you could say to the left of the mean. Let's calculate the last two scores. 72 minus 60 over 8 is equal to 1.5, and 30 minus 60 over 8 is equal to negative 3.75. Now we are done with the question, but I'm going to graph the z-scores with the corresponding x values because I think it helps visualize what's going on. So these are the z-scores, and these are the corresponding x values. 0 corresponds with 60 because that's the mean. 1.5 corresponds to 72. Negative 2.5 corresponds to 40, and so on.